That's a comment. You can skip that. Here's a pitch table. These are pitches to do with different notes: A sharp, B, C, etc. And this list of pitches is used to generate the MIDI pitch table. Notice this is just 1 octave worth of notes, but the MIDI pitch table is many octaves worth of notes, and there's a function that does that. Here we've gotten to the setup. So finally the program starts to run. The first thing it does is run the setup. If the MIDI output is on, set the data rate of the transmit pin to 31250, and that will allow you to send MIDI data at that data rate. That's the MIDI data rate. If the MIDI output is not on, instead we're going to set the serial data rate to 9600, which is serial debug. If serial debug is on, print all this crap. Say that we're auto calibrating, stay clear of the light sensors, yada yada yada. Set pin directions and auto calibrate. Okay, so this is pretty standard stuff. Calc MIDI pitch table, that's the function I was telling you about that turns that short list of frequencies into a huge list of frequencies for the piezo sound. Auto calibrate, this goes through and puts all those backscatters into the threshold array. The prox detect function is a neat little function that does that backscatter detection, and we'll get to that later. Zero MIDI velocities, this just clears the MIDI velocity table. Copy new to old, that copies MIDI velocities to MIDI velocities old, and here when the two functions being called together has the effect of zeroing both of them. And now we've gotten to the loop function. First thing we're going to do is scan the light strings, and that is doing all the proximity detection and deciding whether the notes are going to be triggered or not. This is checking for control combination. That would be changing modes like chord trigger mode, arpeggiator, or single notes. Modulation cue. Now this is a light string combination currently set to the 7th string plus any other string. This will cause your chord's moods to be inverted or changed to a different mood. So if it's a major chord, it becomes minor, and vice versa. Zero MIDI velocities. This is starting out here, just wiping out all the notes that are there in the MIDI velocities bank. And now we're going to go through and we're going to decide what those MIDI velocities are going to be. So we count through all the strings. We say if this string is triggered, then the MIDI note equals the MIDI tonic, which starts off as 60 or middle C, plus scale I. So it's going to depend on what note it is in the scale, how much we're going to offset it from that MIDI tonic. The velocity, 64 is half of 128. We're adding that regardless so that it's audible regardless. You can change that. You can get rid of that if you want to, whatever. Plus backscatter I. So we're gonna add the backscatter onto that velocity so it'll be louder if there's more backscatter or if your hand is closer. If the velocity is more than 127, that's not good because MIDI wants it to be 127 at maximum. Then the velocity is reset to 127. That limits the range. Insane mode, again, this is just arpeggiator mode. I'm going to probably rename it, but I thought it was cute to call it that. This is deciding, this is picking a note in that chord and deciding to play just that one note this time around. Piezo pitch, looking in the MIDI pitch table for the given note and getting that frequency. Note on, MIDI note velocity. Now this is just putting a note into the MIDI volume array. MIDI velocities array that is just saying turn that note on. And there are 128 possible notes, so there's 128 slots in that MIDI velocities array, and depending on what note's being turned on, that's the slot that is given a velocity in that array. If chord trigger mode and not insane mode, that's just regular chord trigger mode, then we're also going to play a third, and we're going to play a fifth. And here's our piezo beeps. If piezo sound output is on, then we're going to freak out, frequency out to function. This to the sound out pin, the piezo pitch. So we're going to send that frequency to the sound output pin or the piezo pin, and we are going to do that for this amount of time, standard delay, which is in milliseconds. And then pulse velocity equals 0. I think that's probably not even necessary. I don't even think that velocity variable is used. If MIDI output on, refresh MIDI output. Okay, this is important. Refresh MIDI output, that's that function I was telling you about that looks for changes between the old MIDI volume, MIDI velocities, old and MIDI velocities, and where there are changes, it does the appropriate thing. If there was no note and now there's a note, turns the note on. If there was a note and there's no note, it turns the note off. And it's doing this by sending data, out via the MIDI connection. If there was no note before and there's still no note, then do nothing. And if there is a note, if there was a note before and there still is a note, then you can adjust the volume via aftertouch. So there's really 4 different things that it can do depending on the comparison. MIDI debug. It's not really important. Insane mode, delay. Okay, so only if we're in the insane mode or the arpeggiator mode, we're going to put a delay in here. And that's just so it's not going like brrr, really fast. It slows it down. So it's only playing 1 note per cycle. It's going to slow it down, and it's going to play. It's going to cycle more slowly so that you can hear each individual note distinctly. Calc MIDI pitch table. This function is calculating all those lovely MIDI pitches for the piezo. 0 MIDI velocity, this is just zeroing out that table. Fade all active notes, I don't use this function anymore. It was something I wrote earlier. Refresh MIDI output, that's that function I was telling you about that looks at different cases, let's see. MIDI send, this function is being called. This is what's actually sending the MIDI data over over that serial connection. Copy new to old. Debug MIDI stream. That's what all this does is just say asterisk if a note's been triggered and a dot if it hasn't, and it goes through all the possible notes, 128 possible notes. Wouldn't bother with it now that the MIDI system is solid. Object proximal, this just decides whether the object is proximal by the definition of the threshold coefficient and the threshold offset after you've already determined the backscatter. Scan light strings. This is the function that goes through and scans all the light strings sequentially. Calls the prox detect function, which is what's actually going to turn those lights on and off and read the sensors and everything.